We all know that music is an integral part of audiovisual media such as films and also of interactive media, and here foremost video games may come to mind. And in this interactive context, ambient music, this particular musical genre, comes with some quite interesting perspectives that I want to discuss in this presentation. First things first, music in films as well as in games fulfills some narrative functions. It's not just there to entertain, but also to emotionalize, mediate the feeling of immersion or associations, and affect our sense of time and stuff like that. This classification that we see here has been done for film music, but it also accounts mostly to games music. But in games we have a slightly different situation. Because our audience isn't passive anymore, they are active participants in the interactive narration in the virtual world. And from this, here we have the situation that the music does not only play in context of what is going on screen, but also in the context of what the player does and how the player interacts. And there can be kind of a dialogue between player and music as part of that interactive medium. And from this emerges a variety of new narrative functions that are unknown to film music, such as affecting playing behavior, decision processes, and even the player's self-image. But we don't only have new interesting possibilities here to use the music, to do something with the music. We also have some new challenges, especially regarding the montage of music and the interactive scene. Well, this first statement is already well known from film music and occurs quite frequently in the literature. Background music shall not be heard. Of course, this doesn't mean that it should be as quiet as possible so that no one can hear it. It refers to a subconscious listening attitude where it is said that the music affects the listener in a more emotional way than in typical concert situations where you have a more analytical kind of listening habit. According to this often quoted phrase of Brian Eno that we saw yesterday already 2 times, we can see that ambient music seems to be quite predestined for that purpose, or for that situation here, because it features corresponding compositional paradigms to actively keep in the background and don't necessarily attract attention. Then we are in an interactive scene, and this means we don't really know when something happens and what happens next and how long it takes for the player to, for instance, solve a certain puzzle and proceed in the game and so on. And this could be quite long this time. Music has to keep up the required mood in this situation as long as necessary. This is mostly achieved by repeating one and the same piece of music again and again. But we don't want the player to recognize this repetition, because in this situation, at that point, it mediates to the player that the whole game is in an idle state, idle loop, just waits for you, player, to finally solve that puzzle and proceed in the game. This can become quite frustrating. And after a while of the ever same, it also becomes annoying, and this is the situation when the players often interrupt the game, change over to the options menu, and switch off the music. And this is definitely something that we don't want to happen. Again, ambient music, thanks to its reliance to non-developmental forms, also non-developmental forms of variation, seems to be much better suited to fulfill this task than other musical genres are. Also, the opposite situation is a problem. The player rushes through the scene, and the interactive scenes are much shorter than we expected. Music has to follow. Players don't wait for the music. Music has to follow and react at short notice when something changes. Again, here we have a solution that is not so good. It's usually achieved, this musical change is usually achieved by hard cuts such as this one. Which is not just unmusical, but also how to say it, it mediates a kind of fragmentation to the scene, or the scene is perceived as more fragmented than it actually was intended to be by the game developers. There may only be horror games with shock moments where you really want to have this abrupt change, but in most other situations, and more generally speaking about games, you don't really want this abruptness in these changes. Also, the other montage techniques here, short crossfades and quick fade-outs, are not really a solution to this problem. They are still asynchronous to the music and interrupt with the musical flow, so to say. Generally speaking, linear pieces of music are hardly suited to follow a nonlinear interactive narration in a musically coherent way. Luckily, there are several approaches to introduce nonlinearity to music, of which the first two can already be found in games today. Dynamic sequencing of pre-composed musical snipping and dynamic mixing of multi-track music. This is something that the gaming industry uses today already, and it's quite well exploited. The remainder of this list, however, is more or less academic so far. Expressive performance, this means that we have that we actually don't really switch to a different piece of music. We keep the current piece of music running, and we only change the way it is performed to change its character of expression. You will immediately hear what this means in this sound example. You will also hear some bing sounds in between. These indicate that the player triggered that musical change, and then you can hear the virtual musicians react on it. The idea behind reharmonization is a bit similar. Again, we keep the current piece of music playing on, and this time we adapt the voice leadings and the polyphonic counterpoint to get to play different chords in the music. We experimented with this idea, but it's still in its infancy. Generative transitions. This means that we have two pre-composed pieces of music. One is currently playing, the other one is our target music, and while the current piece of music plays, at some point we get this trigger, the bing sound, to transition to the target music. And this time we again adapt the voice leadings and create a harmonic modulation to the target music and seamless connections in terms of voice leadings and so on, so that we get a good connection to the target music. This approach, this idea is so far just an idea. It's pretty theoretical. There isn't a working solution available for this so far. Yeah, and finally, generative music. Here the idea is that we have an algorithm generating the music in real time while we are playing the game, and we can tweak the parameters of that algorithm to achieve musical transformations. By the way, Brian Eno also did some generative music for a video game called Spore. So this is at least something where we can find very few examples of generative or procedural music in games. Okay, to investigate these things a bit further and see how much more flexibility we can bring into the music and what we can do to control the music, we developed two different music engines, AmbientMusicBox and AmbientMusicGenerator. I'm not so good in finding interesting names, so yeah, box and generator, this has to suffice for today. Let's see what we can do with these two different approaches and what we learn from them. AmbientMusicBox, that's a script engine. It reads an XML script. That XML script is the actual composition, the music, the musical piece, so to say. These scripts are parsed in real time and synthesized using JSON, that's a sound synthesis framework for Java. the most comprehensive sound synthesis framework for Java, actually. And this is then played in real time. Here you see some of the XML elements that the composer would use to define the music. Voices are exactly what you would expect them to be, musical voices or parts. They represent instruments that are JSON scripts or JSON patches that you can associate here. You also have this relative mix parameter here. All the parameters are accessible also during the playback, so dynamic mixing is quite easily possible here by editing this parameter. And these voices can have two types of child elements, waves and sequences. Waves, these are audio. This is static audio data that can be loaded and played back as one shot or as a loop. And they can be used for whatever you want to use audio data. Here, for instance, is some background soundscape. I know this seems a bit like a cheap cliche here, but in games we usually have the situation that we have a narrative, a virtual scene with a certain soundscape, plus the music playing on top of it, or together with it. And the music is defined by sequences, one or more such sequences. They can also be looped. There is one starting. The sequences are defined by nodes and rests. With this, it's already quite easily possible to handle this compositional paradigm that can be found in ambient music quite frequently of asynchronous sound event loops. For instance, yesterday the flight of the monarchs also seemed to work. Where is Rob?
He's gone through rehearsal.
Okay. He described his compositional approach there also with these sound loops. And there is another XML element that can be used, procedures. Procedures are used to introduce nonlinearity or non-determinism to the music in terms of random choice or permutations. So you have some child elements in these procedures, such as further sequences or nodes, and these are then randomly chosen. Here, for instance, it's two node sequences, of which one is chosen whenever we pass the procedure in the musical playback. Here, permutations where we have a sequence that can be changed later on. With these few building blocks, we can already define quite complex pieces of music, because sequences can be nested within sequences, and we can have procedures within sequences within procedures, and so on. So there is indeed a lot of possibilities that to define interesting musical structures and aesthetics. Now, what do we achieve with this approach? We have sequential arrangement, dynamic mixing. This is easily accessible here in AmbientMusicBox. We have access to some few expressive performance parameters. It's actually just velocity, keystroke velocity, and note duration, tone duration. Not much more than this. And we have the possibility, by accessing the scripts, to change the pitch values of the notes and thereby achieve a reharmonization. But at this point, I really have to say, now we get into techniques that are not so convenient for game developers. Usually game developers don't really know what to do with these scripts. They don't usually have a musical background. So it requires the composer not just to compose the scripts, but also to plan ahead how to adapt the scripts, which parameters to change to achieve certain transformations. So everything is more or less pre-composed, even though with these procedures, some things, it's possible to have more non-determinism. But the effort to get this flexibility into the music is still quite high, and most game developers will probably not really do something like that. It's theoretically even possible to generate these scripts while they are parsed. So even this is possible, but and it would mean we are here in this region, in this area. But as I said, with this approach, AmbientMusicBox and the API, the application programming interface that provides only high-level control really and access to the script, we are quite stuck to the pre-composed material and thus not as flexible as we thought we could be here at this point. And this leads us to AmbientMusicGenerator. This is really a real music generator approach, a real generative music approach. We have an algorithm generating the music. We have this algorithm has certain parameters which correspond with structural properties of the music, and these are passed on to the application via the application programming interface, the API. And in this case, the application is just this graphical user interface that we see here. Generation and sound synthesis are done in real time, although I have to say at this point, our experiments with AmbientMusicGenerator, here the sound synthesis was not so much in the focus, because, well, sound synthesis can be very flexible, of course. Just look at the 9 conferences and you see lots of examples what you can do on the sound synthesis level. So there's nothing important to discover here. We really wanted to see what we can get, how much more flexibility can we get on the compositional or on the structural level of the music. So you are warned now that the sound synthesis is a bit cheap here and cheesy, but it will suffice for demonstration. And while this is playing, let's have a look at the interactive parameters that we have here. Tonality, basic chord, and pitch range. This stuff is controlled here and also in the single locally for the musical voices. Tempo, phrase length, phrase density, and ultimately also the density of sound events. Some of that stuff is controlled here. We have an arpeggiator module that creates its own patterns and varies these patterns by permutation. And we have a melodic phrase generator that is based on hidden Markov models. These Markov models can be retrained on the fly. That means you have a set of melodies to train the Markov model so that it creates similar melodies. And you can switch that set of melodies on the fly, and the Markov model will then also switch the kinds of the kind of melodies. And you can also change the order of the Markov model to on the fly. What else? And we have, of course, again access to dynamic mixing and to some sound synthesis parameters. While recording this sound example here, I was just playing around with these parameters a little bit, and it is thanks to this genre of ambient music that it is so easy, also on an algorithmic level, so easy to introduce these modulations to the musical aesthetics or the musical structure. In other genres, let's say in Baroque music or whatever else, you have to cope so much about or worry about counterpoint, about interrelationships between such parameters and other aesthetic principles. So it's much more straightforward, kind of low-hanging fruits here in ambient music to have this, to get this flexibility. Mainly because of its roots in serial music and also in minimal music. But while experimenting with these parameters, we immediately experienced that that too much change and changing too many parameters at a time still causes musical inconsistency. Because you immediately hear that something changed very drastically from one moment to the next. And this means even these parameter changes have to be transitioned in some way. In most cases, it's simply achieved by, or the easiest way to achieve this is by linear ramps. And yeah, in cases such as this chord, for instance, you wouldn't change all the chord notes at once, but only one at a time, and then wait for a while, and then the next, and so on. So you have something like harmonic modulation going on here. The same for the underlying tonality scale and so on. Yeah. Good, but now, when modulating these parameters, another idea comes to mind. You can actually use data streams, which may come from the game engine, to modulate these parameters. For instance, how much puzzles does the player have to solve until the scene proceeds, the game proceeds, or how close is the player to the solution of a certain puzzle. Or you may even use stock market courses to modulate these parameters. And what you get by this is a musical auditory display and a very close connection or relation between music and the interactive scene and the player interacting in that scene. Yeah, and this is a kind of flexibility that we don't really have with other music, at least not in this way that it is even for the listener relatively easy to understand what is going on in the music and how is it related to the game. Okay, again, game developers don't really know what to do with these parameters. They are no musicians generally. It is required to introduce some high-level control, some abstractions, and we had the idea of all in all 3 different kinds of abstractions. First of all, a composer. This approach still includes a composer to provide musical material. The composer would create presets, for instance, to represent mood or whatever else. And the game engine can trigger these presets. And to transition between presets or to simply adapt these presets a little more fine-grained, composers can provide scripts that can also be triggered by the music engine. So game developers only have to know what to trigger at which situation in the game. And finally, you can also modulate the parameters not by events in the interactive scene, but just in a chaotic or non-deterministic fashion, so that you have musical transformations or musical development all the time, which is especially useful in these situations where players are stuck and you don't really want the music to get stuck somehow. And yeah, let's say after 10 minutes you want the music to sound a little bit different than in the beginning. Yeah, this is what you can achieve with this these chaotic parameter modulations. Okay. What do we get here? Of course, we don't have pre-composed musical material anymore, so these 2 points here are not in the game anymore, but we have dynamic mixing, we have access to several expressive performance parameters. Reharmonization is really easily possible here, and well, it's a generative music approach, so we have lots of parameters to tweak and do really interesting things that are not so easily possible and are widely unexploited in game music so far. This brings me to the end. So seems like the more generative the music is, the more flexible it is. At least this is one way to introduce more flexibility, as we've seen. And this now solves all our problems. Not really. When looking into the practice, things are a bit different because game composers have their established workflows, and these usually don't involve generative techniques, and thus, they wouldn't. Most of the game music composers wouldn't actually use these techniques, or at least are not used to apply these techniques in their workflow. Looking into game engines, we have to state that none of these game engines actually has a music generator or some kind of plug-in technology to allow introducing music generators and even synthesizers of that kind that we need here. So the whole software infrastructure is missing so far to really work with these things in games. And real-time sound synthesis of polyphonic music, especially of very polyphonic music, so to say, is quite demanding in terms of hardware performance still today. And in contrast to this, games require most of the computing power for other tasks, such as AI, physics simulation, and graphics. Especially on mobile devices, we don't really have these powerful graphics cards, so all this runs over the CPU, and so there isn't so much hardware performance left for sophisticated music techniques. Hence we have quite interesting new promising possibilities, but also new challenges.